rate of open today. Is everyone paying attention? Yeah? I mean, Fish did an incredible job with that. I bring a rubber ducky whenever I come to a talk. And does anyone know why rubber duckies are incredibly important in software engineering? This is the time to show your energy, bring your hands up. Does anyone know why rubber duckies are important? Okay, anyone want to shout it out? Debugging, right? This was the OG stuff we used before ChatGPT, right? And I still carry this around with me for two reasons. One is debugging, because this stuff sometimes still works better than Codex. And the second reason is I come from Switzerland, and therapy is very hard to afford over there. And so this helps me with my troubles. But no, thank you so much for me taking you through a couple of dark art today. And the talk is going to be a story. It's almost an extension of some things that were talked about yesterday, right? I talked about bloat yesterday. So there's going to be a little conversation around that. And then afterwards, Dan is also going to be talking about TanStack Query. We'll be putting that into the talk today too. So there's going to be a lot to pay attention to this morning. And the first thing that's happening is my clickers aren't working. So let's switch things up. So who am I? Can just get an incredible introduction. I am Faris. I'm a staff software engineer at a company called Small PDF. Does anyone know what Small PDF is or has used it before? Incredible. Has anyone paid for Small PDF before? That is the answer, right? I'm responsible for payments and monetization of Small PDF. So when hands go down, it means I'm not doing my job correctly. I've also taken a keen interest in web performance as the top today engineering leadership. I've worked on Raycast open source extensions. Can anyone here use Raycast? There we go. V2 beta is out. It's absolutely incredible. There are a lot of things that you could do on Raycast. I highly encourage you to use it because there are no excuses. It works on Windows now. Aziz said, co-founder of Zurich.js and also a Stripe community builder, but that's not what we're here to talk about today. What I want to start with is setting the stage. And by setting the stage, I'm going to show you this photo. Not only am I from Switzerland, I'm also from Pakistan. Over there, that's the attitude, right? And it does. I'm from Pakistan. And this is a very typical scene that you'll see on Pakistani roads. You're going to see a bunch of Toyotas and Hondas that have been used and abused over time, and in no way used in the way that they're meant to be. Some of these incredible vehicles can last up to 620,000 miles. And if you take on the flip side where I come from Switzerland, or if you go to Germany and you go driving on the Autobahn, you'll see beautiful German cars. Beautiful German cars, but if you put just the right amount of oil and the right type of oil, if you put just the right amount of fuel, the right tire pressure, then they may just about hit 300 kilometers an hour, are beautiful and expensive to maintain. I think that this is very similar to the comparison between localhost and the real world. Localhost is our beautiful German Autobahn, where everything is fine-tuned and you've got powerful MacBooks to be able to re-render as many times as we want to react without any consequences. But the real world is more like preparing your platform like a Honda or a Japanese car that's going to stand the test of time. And so localhost, what do we have? We have these stable networks, these great bandwidths. Everyone's either on Ethernet or incredible Wi-Fi connections. You're a single user in an ideal environment. Seldom the case for your real world users. They have to deal with high latency and unreliable networks. You have situations where maybe you're using an application in the train, you're downloading something, you get it turned into a tunnel, connection cuts, and then you got to recover from that situation. You've mixed devices and throttle CPUs to deal with. Not everyone's got the fanciest iPhone 17, although if you have an iPhone Air, I would presume with the amount of heating it goes through, that it's more like an iPhone 13 these days, if you ever tried that out. You're going to deal with partial caches, stale data, and flaky APIs. So what is the puffy statement that we want to go to today? What challenges do developers face in creating seamless user experience due to complex data fetching and management? And all the stuff that I want you to pay attention to is going to be highlighted in yellow. I'm helping you pay attention today. And if you follow the right numbers, you may be able to answer the questions of the quiz at the end of it correctly. So I think this translates into another question. How can we build optimal solutions in suboptimal conditions that we often face? The question to ask after that is, why did he bother doing this? 0 to 2 seconds is the golden window for anything loading. Actually, you want all our websites to load in 0 seconds. We all going to be hacker days, right? Like Ryan showed us yesterday. really fast to load, but that's seldom the case for all of our platforms with complex needs. And so I want to introduce to you the response times and 3 important limits to consider this expert from the Chapter 5 Usability Engineering. I highly recommend it. So at 0.1 seconds, a user feels that a system is reacting instantaneously. It's instant. You click on something, it does what it needs to do. It feels like magic. Once you move over 1 second, this is the limit for a user's flow of thought. If you have a complex series of actions you have to perform on a website, you're clicking through this, you're moving data, you're interacting with widgets, the second something takes longer than a second to do what it's supposed to do, you're breaking your flow of thought, which means you're stopping your train of thought, and that means you're no longer operating in this state of fluidness. And I would even argue that the timings of these are changing in the modern world, because in that book, in that excerpt, 10 seconds is the limit for keeping users' attention. And when's the last time you actually waited 10 seconds for a non-government website? Not very long, right? Not very many of you. To bring some other numbers aboard, 32 seconds is the bounce rate probability as a page load goes from 1 to 3 seconds. The second you go from 1 to 10 seconds, that number shoots up to 120%. We're getting less and less patient as we use the web. And so the technologies I'm talking about today, not necessarily new ones, but incredible ones. That JS, React is the library, then Next.js is the framework, and TanStack Query, who has been having a great week. So I'm sure you can be directed a lot of questions to Dominic afterwards. And it's a powerful asynchronous state management library. I think it's a wonderful way to say it, because I've often seen people confuse TanStack Query as just something for data fetching, and it's really powerful for managing global state. So after understanding these technologies, we also have to understand APIs, because APIs are what we interact very frequently with. These REST APIs, GraphQL APIs, so on and so forth. But I like to split them not by whether it's your gRPC or your GraphQL or your REST, but what are public APIs that we deal with? Public APIs may be the Star Wars APIs. Anyone ever use the Star Wars API or the Pokemon API? It's like this awesome GitHub list, this GitHub repo of public APIs you can use, and you can create wonderful applications out of it. And what's dangerous with that, as exciting as it is to build something, is that they're a black box. You have no control over these APIs. So they're subject to breaking changes. They don't have to abide by semantic versioning if they don't want to. They can just go rogue at any point in time. And so that means you have to build your platform around this assumption that you don't know what this API will do. If somebody's hosting this thing for free and you're not paying for it, then you can't assume it's going to abide by any level of availability. And so that's an assumption you have to bake into your platform. Then you have internal APIs that you deal with. These are designed for internal consumers. Very typical in the case of our front-end team or back-end team or cross-functional team, and your back-end team is designing an API specifically for front-end consumption. So over here, your API can be freestyle. It doesn't have to abide by being for mass consumption. So you can have limited adherence to REST design principles. You can really do whatever you want in this case, because you could talk directly to your internal consumers. You may be lacking authentication because you don't think that anybody's going to be abusing it. And then I want to introduce what we're going to be focusing most on today, which is partner and product APIs. And so these are APIs that your company may be building that are also sold to third-party consumers as a product. Very typical example of this could be Stripe, right? Stripe has a set of APIs they make available to everyone to be able to transact with and be able to process payments, but they also have an internal dashboard. And so they're internal consumers of their own APIs and produce them for external usage. So they do, in fact, have to abide by deprecation policies, whether it's 6 months or 9 months, they have to warn you that something's no longer going to be available. They have to abide by semantic versioning. You need to be able to pin something to a second version number to ensure stability. They need to optimize for widespread compatibility instead of internal optimization. They're not just made for their internal Stripe apps, they're made for everyone to be able to consume. So what I want us to do is wake up and put on our tech lead hats and imagine we got our favorite thing, a Jira ticket. Who loves Jira tickets? Woo! Woo! Right? Let's stick with the OT stuff. We have rubber duckies and Jira tickets, right? And so imagine our front-end team needs to design a dashboard chart to display the distribution of birthdays for the top 5,000 users in our system. This is the Jira ticket that we have. It's wonderfully described. I'm not going to go through all the acceptance criteria, but what I will do is talk about sources of data and the limitations. Then everything comes constraints. So the source of data is available via an API that returns a list of users and all their data. Fantastic. You'll have birthdays in there and you got a bunch of user information. The limitation here is a real world limitation I faced a couple of years ago where the backend team working in the startup just did not have capacity to provide an endpoint or a data warehouse which would have been ideal for producing graphs and so on and so forth that returns the required data format, and there's a limit of 1,000 users for each request currently. So we think about this, we're asking for 5,000 users worth of information, but the API provided for us has not been extended to be able to support 5,000 users return to C of requests. So we're going to have to already start getting creative. And let's look at this first architecture diagram. We're going to start with a user interface as we do typically. And what we're going to do is make 5 parallel requests. Yes, Brian, we're here around, right? 5 parallel API requests client side. We're already making those in parallel, so that's great. And then what happens? You want to put a beautiful loading state there. And then there are 2 directions where we can go in. Direction number 1 is the unhappy path. And so in this case, you may choose to persist the loading state and try to retry something. So you may have some internal retry mechanism that exists to either retry every single request or to retry just the ones that fail. This is custom logic that you have in your code base. The happy path is you go, you get that data, you map that data into whatever format you'd like to be able to send to your components. You set that data in state. You render your UI, and let's say somewhere else you haven't handled your state changes correctly, you make a change, something re-renders, triggers a bunch of other requests, and then you risk a 429 when unrelated stuff is impacting requests should not. And so what may a hook like this look like? Maybe we create a use fetch data hook, and what it's doing is getting data from a Faker API. Then we're going to go and do this mapping functionality, which is getting the birth date by month and mapping the chart data, and then we're setting that data. Shall we look at a demo? Shall we look at a demo? There we go. So demo number 1 is perfect for me having a sip of water because it's going to take a long time to load. Oh yeah. We love that. Okay. And we're there. We're a whole 13.3 seconds. Now let's have a look at the payload. Looks wonderful. So we've got their location, we've got their phone number, we've got the street that they live on, we have the coordinates, the time zone. I'm loving the amount of information. We've also got their password in there, all the hashes, the username, the UUI, wonderful. This is the kind of information I want to select to the front end. I love all of this bloat, right? And then let's say I switch to dark mode and the journey starts all over again because he loves stuffing dark modes into our context providers. If you're good at math, which I am not, you will have seen that that's accumulated 1.58 megabyte payload, and 80% of the data is just not used. So what are the key factors of this initial implementation? You got custom retries. They need testing, they need maintenance, they're subject to bugs. You don't get that. There's no cache by default. Even if the data wasn't considered stale, we're still refetching it because of the dark code change. Now, this thing is complex to manage globally. There are a lot of things that could go wrong. We love using use effects. And then data mapping effort needs to be handled on the client side. And there's potential need for our use memos and our use callbacks to make sure that we're dealing these appropriately and, maintaining referential stability. And the payload is not one bit optimized for state and for caching, because if you're caching this in local storage has limits depending on the browser between 3 and 5 megabytes. So if you're just stuffing all of this in the local storage, and I'm sure this won't be the only requests you're making on the front end, you're going to run out of resources pretty fast. Now, does anyone know why 14 kilobytes is an interesting number when it comes to network requests? Wonderful, so I could explain something new. So 14 kilobytes fits in a single initial congestion window, minimizing round trips and network requests. And I like to visualize this a little bit. If you want to see a 14 kilobyte website, over here you have this image, can I see a website? It's under 14 kilobytes, so exactly the amount. You got all of it, boom, says text. Let's say you got a 15 kilobyte website. You want to see the website, it's going to return the first 14 kilobytes to acknowledge that. Can I see the rest of it? It's going to return the final kilobyte, and then there's a round trip that takes place. And the difference between a 13 and 14 kilobyte website could be less than 10 milliseconds of additional time. The difference between 14 and 15 in this scenario could even be up to 15 per milliseconds. And we'll kind of figure out why this is the case. This 40 kilobytes rule or thing is more obsolete in terms of wording these days, but the principle does apply because now for certain modern CDNs, it's more closer to 46 kilobytes, or it varies, so you can't just optimize everything for 14 or 46 kilobytes. The point is understanding the concept of RAM trips. And to understand it a little bit better, we got to talk about the stall. And the stall is that cost of a single round trip time, RTT. And this RTT depends on your end user. On a LAN connection, it's barely noticeable at 1 to 5 milliseconds. With typical broadband, it could be 30 to 70 milliseconds. 4G, 5G, 800 to 200. So it might be a little bit noticeable. And so the general idea we want to have is to get your critical rendering payload under your initial congestion window. And this is where I want to introduce one of the ways we can do that with a BFF pattern, which isn't new, but this version of it is called the transformation bridge or aggregation proxy. And why they're useful is because you can adapt for platform requirements. Let's say you have a single backend that has multiple clients it's serving, a TV client, a mobile client, and a web client. You have a single proxy that can serve multiple ones. You could decouple concerns there. So everything regarding data fetching, aggregating, so on and so forth lives at this proxy layer. And that you can go and optimize the performance as much as you want, however that data mapping or whatever data structure you're using to be able to transform and get the data into format you want. And just as a little shout out for JSHeroes, all of the code examples are still in Next.js, but the theming is in Nuxt. So maybe JSHeroes will transition. So what is an ideal payload that we saw the one before? It's not ideal. An ideal payload may be this. We want a bunch of buckets, an array of buckets, and we want to say, hey, the count of birthdays is 385 to January, so on and so forth for February and for March, and the total user 5,000. Fantastic. So if we evolve our architecture, what does it look like? We start again on the client, and we're making one request to a Next.js API handler. We've now just moved over those 5 parallel requests to the server side. And so we're still initiating at the loading state. We're making those 5 parallel requests at the proxy level, and we can still enter those 2 states. The unhappy path is fail to return the error code to the client, and then you can go through that whole retry build. Get to the happy path, and you can map the data server side, send to the client, none of that use memo over there, send the state right to the UI, switch to dark mode, and now you're making the same requests all over again. If we adapt our hook, it's going to shift from this to just making the request to the proxy there, and you delegated all that effort to the proxy. And so we've made a couple of improvements here still. What we've done is failure isolation. We've isolated failure to a single client request rather than the client dealing with multiple of them. Let the server handle that. We made a clear separation of concerns in our code base when it deals with how to get the aggregated data for our birthdays in our chart. Mapping is done at the proxy level. And finally, the payload can be optimized to the minimal viable values that we want to deal with in our state and within our cache. Fancy a second demo? You think, let's see if I can still drink some water in that demo, right? That's the test. 5 seconds. Let's open it up. Thank you. One person. One person's excited that we went from 13 seconds down to 5 by just moving a function from one part of our Next.js code base to another. You just did a copy and paste. Don't we love that? And now, if you're still good at math, that was 300 bytes instead of that original payload that we looked at. And so let's think a little bit more about network bandwidth. For that 1.5 megabyte payload, a network bandwidth of 90 megabytes per second, the download time will be around 340 milliseconds. Typical Wi-Fi experience. 4G, which most of the world does have access to, on 25 megabits per second, you have a download time of 700 milliseconds, starting to edge a little bit closer to that 1 second mark. Then with 3G, that some other parts of the world still are predominantly relying on, you're at 6.5 seconds. That's not an ideal place to be. Now, if we take those 300 bytes and run it through the same series of connections, Wi-Fi, 200 to 210 milliseconds. 4G, 200 to 210 milliseconds. 3G, 200 to 210 milliseconds. There we go. Second person. So we hand them hello, we hand over here. The next time I say something, I expect that side of the crowd to react. We're moving through. So we have to understand a little bit more about ingress and egress over here. And so ingress is data coming into a system or network. And so most cloud providers will happily not charge you for this. They'll most likely charge you for egress, which is data coming out of a system or network. And to understand this a little bit deeper, you have to understand the difference between function as a service and infrastructure as a service, because you can handle your BFF in multiple different ways. Your function as a service is your AWS Lambda, your Kepler workers, your Vercel Edge functions, and those have an average ingress bandwidth at 1 to 5 gigabits per second. So it's very hard to estimate that, but much better than what we were having on the Kyle 3G network. They do have cold start times to deal with, so it's a little bit of a constraint, but generally they remain hot for around 5 to 60 minutes. With infrastructure as a service, you got 2 to 5 gigabits per second, and that's your EC2, your GCP compute, Azure BS, and they're always running no cold start penalties, and they may just be a little bit more expensive. This is where I introduced TanStack Query, but I'm not going to go too much into it because that was going to be talking about how to not use TanStack Query later on. And I think this would be a much better way to discover the power of this library. And so most of you who do know TanStack Query, you'll discover a little bit later on. But we're going to add this. We're going to bake it into our solution and see how it does help us out a little bit. So we're starting again on the user interface, and we're making one XJS request to an API handler. But this time, React Queries handling it. We're not doing any of that custom fetch function, that custom fetch hook. Loading state, we're not doing it. TanStack Queries handling it. File requests are still dealt with on the server side. But once we get to the I'm happy path, it's incredibly easy to trigger multiple retries with TanStack Query. Not only that, you can start to implement more creative resilience patterns, not just your standard retries, but also exponential backoff, which is if you're doing, let's say, with 3 retries, you'll do 1, then you'll wait a second. You'll do your second one, wait 2 seconds, third one, wait a little bit longer. You're giving breathing space to avoid thundering herd problems. And if you want to learn a little bit more of thundering herd problems, there's an incredible postmortem that Kyle Farrow, the world-class, postmortems on the use effect outage. You were proud for a second, and then you were like, oh, I knew it was coming. So read word for read to understand thundering herd problems. Now let's say we go over the happy path. We're going to map the data of the server, send it to the client, and we're going to cache it in memory with TanStack. You even do offline cache with local forward for ballistic for in-memory caching. React Query derives the state from the response. You render the UI. React state changes were low for Darvel. Forget the lights. And then we're going to check if there's still something valid in memory cache. There's a cache hit. We're not going to bother. We're not going to bother going for another data fetch. If there's a cache miss, then we're going to go fetch all over again. So we're even compensating a little bit for having not ideally set up our stick manager. And if we see how this book is evolved, we're going to use query as our hook. We're going to pass query keys that allows us to cache multiple combinations of our requests. If we were to requesting more than a quantity of 5, set our stale time, and we're still making that same request at proxy level. Key factors here is we've now evolved to having a third library handle the controls of our loading state, error, and deriving response. You don't have to do any maintenance or testing. All the bugs are there cobbled, right? So you can talk directly to Dominic when there's an issue. You don't have to deal with it. Cache it. It's optimized. The optimized payload can now be cached with multiple strategies incredibly easily. And when it comes to re-renders, you're limiting the refetches and you're managing data staleness in a much healthier fashion, and they provide incredible dev tools to do so. Then you get that configurable resilience out of the box to make sure you're implementing the right strategies and you're hammering your servers when you want data. You need to add a little bit more patience to the way you're making your requests. I still think we can go one step further. Let's say we started the journey on the server side. This is the beauty of what we could do with Next.js, right? We can do things on the server. So let's say we're starting our journey on the server, and instead of making a request on the client, we're going to make that request on the server. So they can one API request to the Next.js handler. What we really need to do importantly here is that your page rendering time now is only as fast as your slowest request. So this is when we need to add another resilience pattern called a timeout. And so if that request does not get achieved within 1,000 milliseconds or whatever limit you put, bail from that request, because in this instance, We're not sending any HTML to the browser. So that means it's a blank screen. And we'll see what this looks like in a second. And if it's not handled correctly, it can actually worsen your user experience. What we're trying to do is, in optimal conditions, have an optimal experience, but in suboptimal ones, we try to get the best experience that we can. And so, cool, we got the timeout control, we got the loading state that React Query is handling, make the request on the server side, fire the first remain at the proxy level. If you're unhappy, you could fail fast and silent. You could choose to do, and then what you can do is fail fast and silent, and then you can go into the UI recovery. In UI recovery, what we're doing is we're bailing on the back end. We're bailing on server and we're saying, we did manage to get to an ideal state where I have this information in the back end. So bail, send your HTML to the client, start to hydrate, start to show some fancy animation, distract the user as much as you can. And we're going to try and recover that same thing on the client side. And React Query has really helped to help this. Then you get the happy path, you set the server cache dehydrated, you set it in your payload, and then it comes and then gets hydrated on the client side. React Query derives that state on the initial render, and it gets that same flow when it comes to cache hits and cache misses. So I think it's a little bit easier to understand in the pages wrapper scenario. So I'm going to show you a little bit of the get server side proxy do you ever use next year. So what we're doing here is we're creating a prefetch. We're creating a prefetch and we're setting a timeout on that prefetch. And I put 2.5 seconds for this timeout. We're not going to get into this concept of optional and critical queries. That's for the 1 hour version of this talk. We can talk about later on. But what we're doing is an optional query. This is just saying that we'll let this thing fail silently if it doesn't get to an ideal state, rather than blow up the UI. We're going to set these query keys over here. We're going to fetch from the same proxy. We're going to return the dehydrated state. And I'm going to pass that into props. And so the key factors here is that we're reducing UI delayed because there's no fetching that takes place on the front end the second the client is loaded, because everything's coming already ready from the server. We're load balancing a little bit, reducing client load and never requests between the server and the client. So we're choosing what do we want to load on the server, what's our critical payloads, and what do we want to do on the client so we don't have an entire waterfall of network requests to deal with if we're loading a lot of data. You have enough data recovery strategies, and then you can, retry the queries. The server prefetch fails, and you can match that on the client side. So what that means is, when we saw the query keys on the optional prefetch, what we can do is match those query keys on the use query that happens to the client. And so if there wasn't any initial state, initial payload, something dehydrated that came from the server, React Query is going to say, hey, I don't have any information, so I need to go fetch. But if it does have that information and it's not stale, then it will follow doing that fetching. So you have this data recovery strategy. Should we look at the third demo, see how that changes things? There we go. We're going to start on the Zurich.js website, right? And what we're going to do is I need to put this first. What we're going to do is we're going to switch to demo 3. Demo 3 is where we had no timeout in place. As you just see this loading spare, because not set anything to the client. Even though everything immediately loads, that doesn't mean it's an ideal experience because it took so long to initially load. Now, in this fourth example, it took longer than a second to fetch the data on the client server side. So we bailed, we resumed loading on the client side so that I didn't have the data, and we're trying to recover and get into an ideal state. And so if you were super fast on demo 3, and you would have just loaded things immediately, had that spinner for a long time, happy days. But if you're on a really bad network request, then you bail from that, get into a lower state, maybe the user can do something else, and then you're trying to recover. So what about the real world results? Where were these demos done? On an airplane. All of these were recorded on my flight to New York to speak at React Summit in New York. So I was right over there in the sky. Don't worry, it wasn't a 4G connection on the ground. And those were the network conditions that I was dealing with for all of those demos. So on an airplane, we went from 13 seconds to 3. And that, I think, is a pretty cool experience because I've never had a good time with airplane Wi-Fi. Now, Faris, instead of jumping through all of those engineering hoops, couldn't the backend have just made the TAD endpoints? And that is never going to be the point. The point is to be pragmatic, but also to be curious, to be creative, and thank you for your time.